this lecture I will be talking about some of the devices used for power system protection. Well, when I say about device and protection, the first thing that comes into our mind is fuse, because fuse is a popularly used protective device in most of the households. It is a simple, cost effective, or I can say low cost and less maintenance device. So it is most widely used on the distribution side and to protect domestic loads and apparatus. If we try to observe what a fuse is actually doing, let us take this house. Let us suppose it is having 3 rooms. In each room there is a fuse. If there is a fault in this room, in this particular room, the fuse, so let us call it as F1, F2 and F3. So when there is a fault in room number 3, then F3 will blow out. Okay, this fuse F3 will blow out. So essentially the fuse here is trying to isolate this particular room or the faulty section from the healthy sections, the other rooms. So fuse here is doing 2 things. The function is twofold. First aspect is that it is able to detect the presence of fault. So if fuse is only blowing when there is a fault, under no fault condition or under normal operating condition, fuse is remaining idle. Okay, it is only blowing out or it is only fusing under fault condition. So it is able to sense or detect the fault. Detection of fault. The second aspect is that it is isolating the faulty section from the healthy section. Isolation of faulty section from the healthy section. So fuse is essentially doing 2 things. Coming to the other apparatus, we also have apparatus like relay and circuit breaker that are used to protect the power system apparatus like transformers, industrial loads, transmission line, and and also in power generating stations, substations. Also, relay and circuit breakers are used widely for protection. Here, the duties that are shown here, detection and isolation, are shared among them. Like relay will only detect or sense the presence of fault, sense the faulty condition, and the isolation part is taken care by the circuit breaker. Isolates the faulty section or faulty machine or apparatus, okay, from the rest of the system. Okay, so isolation is done by the circuit breaker and relay is doing the fault sensing and detection. Okay, relay cannot isolate the faulty section. Relay can only detect. In the same way, circuit breaker cannot sense the fault. It can isolate the faulty section from the healthy section. So how does circuit breaker get the information that there is a fault? So circuit breaker isolates the faulty section from the healthy section upon intimation or upon trigger by a relay. So the relay has to inform the circuit breaker that a fault has occurred and you have to do your duty, that is to isolate the faulty part from the healthy section. So circuit breaker's operation is initiated by relay. Okay, relay sends the fault information to CB, or in other words, relay initiates the CB to operate. CB in the sense circuit breaker to operate. So they are mutually dependent on each other. Relay cannot isolate, circuit breaker cannot sense the fault. So they are not standalone devices. These devices, relay and circuit breaker, should be used together for proper protection. Whereas on the other hand, if we go to the fuse is our humble fuse present in our home is doing these two things by itself. It is detecting as well as isolating. So fuse is we can say fuse is a standalone device. Standalone device. In the sense, fuse alone can do the work, both the detection and isolation. Whereas circuit breaker and relay are not standalone devices. They have to be used mutually. We have to install relay as well as circuit breaker for proper protection of the system. Okay. So coming to some of the drawbacks of our fuse, although fuse doesn't cost much and its maintenance is almost negligible, it suffers from some of the drawbacks, like fuse is a sacrificial device. In the sense, it blows out after each operation and it has to be replaced or rewired. It has to be replaced or rewired after every operation. Okay. So whenever a fuse blows out, fault has to be rectified first, and then manually the fuse has to be rewired if it is a rewirable fuse, or if it is a cartridge fuse, a new cartridge has to be replaced. So this takes some considerable amount of time. We are taking time here is spent on clearing the fault, as well as time here is spent on rewiring the fuse or replacing the fuse. So that is one major drawback of the fuse. Also, fuse is not very sensitive for low fault currents. Okay, it may not be able to detect those currents that are just slightly above the rated current. Okay, so these two problems are eliminated here by using circuit breaker and relay combination. Eliminates these two drawbacks. We need not replace the circuit breaker after every operation. Okay, circuit breaker, I will just give you a picture what does say circuit breaker actually contain. So circuit breaker here is having a chamber, and in the chamber there are two contacts. Okay, one contact is called the fixed contact, and the other contact is called the moving contact. So whenever relay gives the signal to the circuit breaker, so relay has to initiate the operation because relay is sensing the fault. Whenever relay senses the fault and it intimates the circuit breaker, what circuit breaker does is circuit breaker isolates the faulty section. For doing the same, circuit breaker will separate its contacts. In the sense, its fixed contact will remain where it is, whereas its moving contact will be pulled apart to isolate the faulty section. Okay, so there is no melting or burning of any wire like that of a fuse. Okay, although the separation of contacts will result in the formation of an arc. An arc will form. This is arc. An arc will form when the moving contact is separated from the fixed contact. So to extinguish this arc, we have some arc quenching medium. So this arc quenching medium is present in the chamber of circuit breaker. In the chamber of circuit breaker. So here in this chamber, some arc quenching medium is present. So this arc quenching medium may be oil, maybe a blast of air, maybe vacuum, maybe SF6 also, sulfur hexafluoride. We will study about this when we are study about these things when we are discussing about circuit breakers. But as of now, you just remember that circuit breaker is having a closed airtight chamber, in which there are two contacts, fixed contact and moving contact. And whenever relay intimates the circuit breaker to operate, or whenever relay senses the fault and initiates the circuit breaker operation, circuit breaker pulls apart its moving contact and an arc is formed. This arc is quickly quenched by some arc quenching medium. Okay, so after clearing the fault, the moving contact can be brought back to its initial position. So this can be done by an operator. After clearing the fault, operator can close the moving contact, or he can also operator can close it manually, or he can also operate the circuit breaker by using a remote control also. Okay, here we need to keep in mind that replacing the fuse or rewiring the fuse in case if it is a rewirable fuse, in case if it is a cartridge fuse, we just replace the cartridge. So replacing the fuse will take more time, than reclosing the circuit breaker, Okay, so the time taken to rewire or replace the fuse will be more when compared to the reclosure of a circuit breaker. So usually for wherever it is affordable, circuit breakers and relays are used, and the application of fuse is limited to low voltage applications, especially on the distribution side or on the or at household purpose. Okay, coming to the relay now. Here relay, it senses the fault, as I told you, So its operation depends upon some electromagnetic principles. There are various other technologies for relay also, like microprocessor based relays, static relays, numeric relays. But in our course, I will be confining to electromagnetic relays because it is an undergraduate level course. Okay, so in electromagnetic relay, we may use electromagnetic attraction or electromagnetic induction for relay operation. Okay, how does the relay sense the fault and all, I will try to explain in the coming lectures. But as of now, remember that relay is an electromagnetic device, and electromagnetic attraction or electromagnetic induction is used for relay operation. Okay, so since relay is sensing the fault, see, let us take a system. So there is some load connected here. Okay, this is load. So circuit breaker will be present here. Its two contacts will be here. Okay, whenever there is a fault, circuit breaker's contacts will open. Okay, for opening of the contacts, only moving contact will be moved, fixed contact will remain in its place. So circuit breaker will come to know about the presence of fault when relay gives the information about the presence of fault. Okay, in the sense, relay should be connected to the system, then only relay can sense the presence of fault. Let us take current. So current, let us suppose normal current is 5 amperes. Okay, so if current exceeds 5 amperes, let us suppose it is 5.5 or 10 amperes, okay, or 12 amperes, anything above 5 amperes or anything above 5.5 amperes, let us suppose is treated as fault. Anything above 5.5 amperes is treated as fault. So whenever there is a fault, the current exceeds the normal current. And relay has to sense this increase in current. So if relay has to sense this increase in current, it is to be connected to the system, right? So relay has to be connected somewhere so that it can measure or it can feel the increase in current. So can we connect relay directly here so that it gets the it experiences the flow of current? It is possible, but we usually don't do like that. Why? Because if we connect the relay directly to the system, then the rating of the relay should be equal to the rating of the system to which it is connected. It means the relay should be able to tolerate the current of the system to which it is connected. Okay, so that increases the cost and size of the relay. What we actually do is we step down the voltage, we step down the current, and then we feed it to the relay. Let me show you. Okay, I'm taking the same system. So there is a load here. We have circuit breaker. It has two contacts inside. Okay, so here we have a current transformer CT. So this will step down the current, and from current transformer, this current information is given to relay, and relay is connected. Relay gives information to circuit breaker. By this mechanism, by this connection, what we are doing is we are stepping down the current. So let us suppose it is a 100 by 1 ampere CT. In the sense, if 100 amperes is flowing in the line, 1 ampere will flow in the relay. 1 ampere will flow in the relay. So this relay rating will be low here. If we connect the same relay directly to the system, then the relay rating should be very high, so that it should be able to tolerate the normal load current as well as the fault current. Okay, so if it is directly connected to the system, but since we are using a current transformer here to step down the current, then the size and cost of the relay, or the magnitude, or the what I can say, the rating of the relay will be drastically reduced. So that will reduce the size and cost of the relay. That is one aspect. If it is an overcurrent relay, if it is a current relay, but if it is a voltage relay, we will be using a PT here. We will be using PT instead of CT. Some relays also sends information from CT and PT. Okay, those are called impedance relays. Sorry, those relays are called. So some relays use both CT and PT. So current is stepped down by using CT. Voltage is stepped down by using potential transformer. So both these are used, and the information of current and voltage is passed on to the relay. Such relays are called distance relays. We will also study about those relays. So here what essentially we are doing is we are using instrument transformers CT and PT, so to reduce the magnitude of voltage and current that is fed to the relay. By this we are scoring some advantage, that relay rating is reduced, its cost as well as its footprint is reduced. Okay, so here in this lecture I tried to tell you what are some of the drawbacks of the simple fuse, and what is the basic function of relay and circuit breaker. Okay, the take home points here are: relay is a sensing device. It can only sense the fault. It cannot isolate the fault. Relay initiates the operation of circuit breaker. After sensing the fault, it sends information to the circuit breaker to initiate its operation. Circuit breaker, upon receiving the trigger input, or receiving the fault input from the relay, circuit breaker will isolate the faulty section from the healthy section. So these two are the points that we need to remember here, and this concept should be very clear: what a relay is doing, what a circuit breaker is doing. Okay, kindly please subscribe to our Easy BTech channel. Here we are trying to provide you free content for targeted for all the BTech courses of India. Kindly please like our videos, share and subscribe to our channel. Thank you.